Okay, question 13 has given us a storage tank made by a cylinder with a hemisphere on top. The tank, yeah, that's what it says. The walls of the tank have negligible thickness. Cylinder has a radius r and a height of h. Hemisphere has a radius of r. The volume of the tank is 6 meters cubed. Okay, and it's told us the volume of a sphere and the surface area of a sphere. So if we write down the volume of the sphere, let's take this shape and move. Okay, so we know the volume is 6 meters cubed. We also know the volume can be found by doing area of the cylinder, the volume of the cylinder, which is pi r squared h, plus a half of the volume of a sphere. So a half of 4/3 pi r cubed is 2/3 pi r cubed. So we know that that's equal to 6. But if you look up here, that's nothing like what we've got here. And this is to do with surface area. So the surface area, this is for volume. The surface area is going to be the circle at the bottom, so pi r squared, plus the surface area of the curved part of the cylinder. Now the curved part of a cylinder is a rectangle with a height of h and a length of the circumference of the circle, this length here. If we think about what's happening around here, that, if you open that up, will be this length across the top. So that's the that's going to be 2 pi r. So we've got 2 pi r h, and then we've got the surface area of the cone on the hemisphere on the top. So that's going to be half of 4 pi r squared. So that's 2 pi r squared. So if we collect that together, we've got 3 pi r squareds and 2 pi r h. But what we can also do, okay, so then what we want to do is we want to eliminate this h. So the way we're going to do that is we're going to make h the subject of this, the volume formula, and then substitute it into here. So in order to do that, so let's just rewrite the pi r squared h plus 2/3 pi r cubed is equal to 6. So pi r squared h is equal to 6 minus 2/3 pi r cubed. So h is going to be equal to 6 over pi r squared minus 2/3 pi r cubed over pi r squared. So the pi's are going to cancel, and most of the r's are going to cancel. We're going to have one extra r on top here. So h is equal to 6 over pi r squared minus 2r over 3. So we can take that and now substitute that into here. So the surface area is going to equal 3 pi r squared plus 2 pi r times 6 over pi r squared minus 2r over 3. That's going to give us 3 pi r squared plus 12. The pi's will cancel. We're going to have r on the top, r squared on the bottom, so that's just over r. And then here we're going to have 4 pi r squared over 3. We can collect the pi r squared terms together. We've got 3 minus 4/3. So that's going to be 9/3 minus 4/3. So that's 5/3 of pi r squared plus the 12 over r. And hopefully that's what we've got. Yeah, 12 over r plus 5/3 pi r squared. So that's our surface area formula. Okay, part B then asks us to use calculus to find the radius of the tank for which the surface area is a minimum. So we've got the surface area formula here. If we differentiate this and set it equal to 0, we will find the minimum point of the function, and that's what we're after. So if we differentiate this, if I call that s, then ds, well, let's put it into the right form first. We need this to say be a negative power, so 12r to the negative 1 plus 5/3 pi r squared, and differentiate that. So ds by dr will equal, I need to move the power to the front and take one off the power, so that's negative 12r to the negative 2. R is the variable, so again 2 to the front, so that's going to be 10 over 3 pi r. When that's 0, we'll have our stationary points. I'm going to write this as negative 12 over r squared. And then I'm going to times each term by r squared to get rid of the fraction. So that's going to be 0 equals negative 12 plus 10 over 3 pi r cubed. If we make r the subject, we're going to have 10 over 3 pi r cubed equals 12 times by 3/10. That's going to be 36 over 10. Divide by pi as well. And cube root that. So work that value out. That gives me a radius of 1.05, is it centimetres? What unit are we in? Metres. 1.05 metres. Okay, for part C, it then wants the actual minimum surface area. So remember that we've found the value of r that gives us the minimum. We just need to substitute that into here to find the minimum surface area. I've got 1.05 metres from part B. I'm going to store that number in the memory of my calculator, the actual real value, which was 1.0464477736, and so on, so that when I substitute it into here, I've got the most accurate answer possible. So that's going to be 12 over that value that I've stored into memory A, plus 5/3 of pi times 1.0505 squared. But I am going to be pressing A when I do this 1.05. And that's coming out at 17.2. So it's to the nearest integer, so 17 metres squared.